Hello everyone. Today I'm going to explain the generation of hydrogen sulfide in wastewater. What's hydrogen sulfide? Hydrogen sulfide is a colorless gas that is used basically in some industries like textile, but in our application today, we're going to see how it's produced in wastewater. Again, it's a very bad smell, like the rotting egg smell, and it can cause irritation to the eyes and respiratory system. It can cause coma, convulsions, and dizziness, headache, weakness, irritability for the membranes and to the respiratory duct. And it can also cause stomach upset. Of course, all of this negative effect depend on the dose and the duration of exposure to this kind of dose. The odor threshold is very little, so basically you can smell it if you have 0.001 ppm. So it's a very strong smell, basically. So how it can be generated? It can be generated via reduced sulfide species. Of course, also, like other volatile sulfur gases, it can be produced by heterotrophic microbes during aerobic and anaerobic decomposition of compounds that contain sulfur. There are many factors that affect the sulfate generation, like, for example, if you have high BOD or biological oxygen demand, or you have limited solubility of dissolved oxygen. If you have limited aeration, of course, this is related to the previous one, the solubility of dissolved oxygen. And if you have higher temperature or warmer temperature, this actually generate more hydrogen sulfide, of course, compared with the liquid, the cold weather. And it can also increased by increasing the rate of fermentation of BOD. And of course, if you have high fermentation products, also it can be related or can be interrelated with the production of hydrogen sulfide. So if you look at this schematic here, what is the pathways for hydrogen sulfide? It can yeah, let's actually, how can actually sulfide is present actually, or sulfate present? So basically, if you have some kind of sulfide here in the wastewater, this kind of sulfide can be undergone the sulfate-reducing bacteria and produce sulfide. This kind of sulfide under, of course, anaerobic condition means that it's inside the water itself. And then this sulfide can be protonated to hydrogen sulfide. And this hydrogen sulfide as a gas can be escaped to the headspace of the wastewater containers or pipes. And then using the sulfide oxidizing bacteria, this can be oxidized to sulfuric acid. And of course, this sulfuric acid can cause some kind of corrosion to the containers or the pipes or the tubes that actually have this kind of water or wastewater flowing through them. Of course, if you have this kind of organic matter, of course, also it can be undergone the methanogenesis and produce methane as well inside this kind of confinement. So again, this kind of sulfate can be found in water because it's actually used generally as coagulant during the production of drinking water. The sewage can contain maybe from 40 to 200 milligram per liter as sulfate, and about half of this can come from the water treatment with aluminum sulfate. Sulfate also reduction occurs in anaerobic areas of sewer biofilm. This basically here, this is what I just said. Is just they have this kind of biofilm around maybe the pipes or about the containers or confinement that contain the wastewater, and this basically this kind of sediment and biofilms basically has this kind of microorganisms that converts the sulfate to hydrogen sulfide and then sulfuric acid in the headspace of this confinement. With that, I hope this will be useful, and see you next time. Bye bye.